Hello everyone, I am Bradley Sward, and today I'm continuing my look into the R programming language. I'm going to be using the 2015 Advent of Code Day 2 problem as my template. The problem is called I was told there would be no math. I don't know whoever told computer science people that. Of course there's math and logic and everything we do. So I'm already kind of pushing the limits of what R is famous for. R is a statistical analysis language. There's a lot of cool stuff you can do with, basically just, doing statistics on a bunch of data, kind of like, think of Excel, but you can program it a lot easier than you can with anything else. And, that's what it's good for. And I'm already starting to push things. And like for problem 3, if I'm going to use a set to figure out all sorts of stuff with moving around and things like that, it's already going away from what R is pretty much, what R is used for. So this might be my last video. Sad to see. So in this problem, I was told there'd be no math. We're going to be wrapping a ton of presents, 1,000 of them in here. And let's just look at this example here. We need to figure out for part 1 how much wrapping paper I need for all of this. And to do that, I have to take, and every present has 6 sides. We're not doing, every present is a cuboid. And so we have to figure out how much wrapping paper to give. So there's 2 of every type of sides. You can see here, 2 times length times width, plus 2 times width times height, plus 2 times height times length. And so I took the 2 out, and I just figured out because I need that for this slack part as well. So I just figured out here, like this. I figured out, take the first times the second, and then take the first times the third, and take the second times the third, and then put that into a little mini list here. And then you can see down here, I take the sum of all of those things and I multiply it by 2. That's exactly what this is doing. And that gets me all the wrapping paper. Plus, if I sort this thing out, and this is where this thing gets a little crazy. This took me quite a bit of time to figure out how to get the data into a format I could use, because R is good at using basically columns of data, and I'm used to thinking of things from a horizontal standpoint. So, because that's just the way data is when you're talking about something in Excel. Basically, you're taking a column of data, you're applying standard deviation and variance, and you're doing, all this other statistical analysis on it from a column standpoint, and it just runs differently if you column major order versus row major order when it comes to this, at least this language. And I am having quite a bit of trouble with this language so far. Just getting at my head around how the data is stored and how to work with it. And so I take the data in. There is no header. I bring it in. I think it comes in as a data frame, and then I convert that into a vector, unlist this thing, and now the data is in the format I'm expecting it to be, where every element in this thing is one of these guys that I can work with. So I'm starting off with a list. The 0 here is the first element is the part 1 answer. The second element is the part 2 answer. And of course, starting out, there's nothing to wrap, so there's nothing here. And no ribbon. I'll worry about part 2 when we get there. You can see my answer there. And so what I'm doing is for each element in this data set, take it, strip it down by its x's, unlist it. And this unlist is a new one for me because of the way this is working out. Take whatever these things are returning, and then turn it into a vector instead of whatever it is. And then, since these are now strings on each of these elements, convert every string element into its numeric/integer form, and then sort them, because I'm going to need to find the smallest or second smallest for part 2. So there's no reason not to sort this guy out. And so it's a lot of work to take that one little string and convert it into 3 numbers, and I'm guaranteeing that the numbers are sorted as well. So now, again, as we were saying here, now take 2 sides, side 1, side 2, side 1, side 3, side 2, side 3, and keep track of that. Notice I didn't put the 2 in there. I guess I could put the 2 somewhere, but I did put the 2 here because I can just I could sum the sides, and then, basically take the 2 out. What is that? Distributive, commutative, additive laws, all those kind of laws from the old mathematics. Take the 2 out, and so I could take basically those elements and sum them up. And I wouldn't want to put the 2 in here anyway because I need to find the minimum side for the slack part of this thing. So, but that's it for part 1. Take all of the sides together, multiply by 2. That gets me the for the proper present. And then when I take the minimum of each of these 3 things, that will end up getting me the slack part. I add all of that together, add that in, and that's my part 1 total. And I do that 1,000 times. I do for every present, wrap that up and figure it out 1,000 times, and then I just keep adding, and this is what I get here. What I got to do? Control A, Control Enter, and then this thing pops up over here, and you can see my answer 1598415. Then that's what I get for the part 1 part. So part 2, like everything else, is a little more challenging. I can show you that I do get the answer 3812,909. And so what am I doing here is, okay, part 1 was wrapping paper, but part 2 is when it has to do with figuring out how to do ribbon. And so for the ribbon part of this, for the ribbon for the bow, we just multiply each of the 3 elements together. So I take the dims, and you can see here I just use prod dims. That's cool. I love, product. I wish I could use the word product, but prod is all right. So I just multiply every element together to get my product, and that's for the for the bow. And then the ribbon the amount of ribbon needed for the present itself is 2 times the sum of the smallest 2 sides, because the ribbon required to wrap the present is the shortest distance around its sides, the smallest perimeter of any one face, which basically just means take the 2 shortest sides, add them together, multiply by 2, because you have to go around the thing, and you have to go, when you go around a cuboid, you have to go around 4 sides. But that said, it's kind of the same thing as the first part. Just take, there's no sorting here. I wouldn't need to sort. Well, actually, I do need to sort in both cases here, in both part 1 and part 2. So I've sorted this thing out. So and another way to do this is to basically, if I wanted to sum the dims together and then minus the largest, that will get me the smaller 2. But different ways to do that. But 2 times each of the smaller dimensions plus the product gets me to where I need to go. And again, so with this in here, I just set it up so totals, instead of setting up 2 separate variables, I use this thing as a vector, and I create a vector to add into the vector, because R is all about doing things from a vector standpoint instead of from an element standpoint, or like just a 1-by-1 kind of thing. And so I paste the information together, and you can see I did get the answer. So that's all I want to talk about here for this video, 8 or 9 minute video here, and maybe whet your appetite again for the R language. But again, I would not be looking forward to doing some of these problems in R. That's just not what R is for. And I'm looking through my statistics book. I would rather spend my time figuring out how to guarantee a standard deviation and a variance and statistical analysis and box plots and sort of things. All the things that R is good for, I would rather be spending my time doing that than trying to work around and using R environments and all sorts of crazy things just to emulate the data structures that don't come with R out of the box. So as always, if I misspoke about something, or if there is a better way to do this in R and you know it, please let me know. And I'd love to learn from you, and I appreciate when you guys text me and when you guys message me here on YouTube or send me emails about how to improve the process here. So thanks for sticking it out. I hope to maybe make other videos in the future when it comes to different languages. We'll see as we go. Advent of Code is always a good one. It's always a fun one. Up until about day 15, when problems start getting hard and the holidays start hitting hard and finals week starts hitting hard as well. Everything just seems to come together at that time. What do you know about that? So thanks for sticking it out as always with me, guys. Have a great day, and I'll see you in another video.